In this video, we solve problem 2 of Unit 15. In this problem, we have a straight wire carrying a current with this sense, and we also have at a distance d, perpendicular to that current, we have an electron moving in the same direction as the current. Okay. So they ask us to calculate the force exerted on the current. On the electron. So this force exerted on the electron is going to be a magnetic force because the current is generating a magnetic field. So first of all, we begin by calculating the magnetic field generated by the current. And we know that the modulus has to be equal to mu sub 0 divided by 2 pi times the current divided by what we normally call r, which is the distance between the current and the point we are. So in this case, this is d. So this is the magnetic field, the modulus of the magnetic field generated at the point where the electron is by the current. To discuss the direction, we have to remember the rule with the mnemotechnic we had with the right hand, and this is you put your thumb following the current, and then your fingers will tell you what is going to be the direction of the magnetic field. So in this case you do this, then your fingers will enter the screen at the point where you have the electron. So that means that the magnetic field, we can represent it by an X, meaning a magnet vector that is perpendicular to the screen and entering it. Okay, so we jotted here, we say that is entering the screen. Okay, so this is the first thing, and now once we know there is a magnetic field in the place where we have the electron moving, we know that there's a magnetic force exerted on this electron because we've studied that in Unit 14. So the magnetic force exerted on moving charge is given by the magnitude of the charge times the cross product between the velocity of the charge and the magnetic field where the charge is. So we already know the magnetic field, and we know the velocity. We're going to take it as v. So the first thing to see is that v is perpendicular to the magnetic field. So we can just discuss what the force is going to be, the modulus. This is going to be QVB, okay? Q, we know it's an electron, okay? So it's a negative charge, okay? This, we have to take this into account to correctly know what the direction of the force is going to be, okay? So we put it like this, and we know that's a negative charge, okay? So for the modulus, we just bring our knowledge of the magnetic field provided by the current. So the force in modulus is going to be QV times mu sub 0 I, the current, divided by 2 pi d, the distance, okay? So this is the force, and to know the direction we use our right hand rule, okay? So we take the velocity with our finger, with our index, the magnetic field with our middle finger, and this makes your thumb point to the left. However, as the charge is negative, this means that the velocity has to have the opposite direction. So it's like this. This is going to be, sorry, not the velocity, the force. Okay, so the force using right hand rule, it's a repulsive.